Today, I'm going to discuss with you the role. One day, I was having my friend. He's a true gourmet. And describe. Meanwhile, I can't do cooking. This lunch makes me wonder, is there a way to quantitatively assess and predict the flavors that makes dishes unique? And that's settle standard problem for this project. How to predict flavor of a food by analyzing its chemical composition. So the first step is to know the complexity of flavor. So flavor combines 3 layers of sensation. The 5 basic tastes, and then which are the on the tongue, and then so many of aroma, the smell, which is chemical interaction on the, and then lastly the mouthfeel, which is the touch on the tongue. So we can simple chemical analysis cannot match the molecules to flavor. We need the help of data science and machine learning. So in the next part, I'm going to research work on focusing on the data modeling. Let's dive into the first and the colleagues in 2021. They focus on understanding the flavor of Arabica coffees. And they brought over 200 brands of coffee and then processed it and sent to a near-infrared spectroscopy to get the spectrum data telling the identity of chemical composition of the coffee. Inside the prediction model, they employ principal component analysis to reduce the complexity of the data and also to showcase the patterns correlating to the spectrum data with the flavor vocab. Then several machine learning models include support vector machine and random forest and residual networks are used to train and find the correlation. After that, they use the DCNN, which is the deep convolution neural network models, to find target areas in spectral areas for flavor prediction. So overall, the models have a 75 to 77% of accuracy. One important thing in their research is that link the chemical information from the spectrum data to a standardized set of coffee flavor vocab, which is defined by association in 2016. And with the help of this standardized vocab, they link up with the spectrum data. After that, the model can find out in the spectrum data which part of the area can tell the coffee flavor and how which part they can focus on and make good predictions. So in the last research, they only focus on the overall chemical composition. But how about breaking down the composition into each of the related molecules and then find the relationship of each of them? This research tells it. The FlavorGraph by Donghyun Park and his colleagues published in 2021 builds a big picture of food and flavor based on some common food ingredients and flavor molecules. They get data from many databases of ingredients, food, and database. And then the results includes some new understanding of recommendation of food pairings. In their FlavorGraph, they have listed over 6,000 of food ingredients notes which is extracted from 1 million food recipe they crawl from website, and then they link the food ingredient nodes to 1.5K flavor compound nodes to build a big network. And then they use the method path to convert this relationship network into machine-readable embedded vectors. And then these vectors serve as the foundation for a chemical property learning layer, learning how flavor molecules in food relate, predicting new science-based food pairings. So this research focus on the general linkage. We can see that on the right top figure, it highlights the shared chemical compounds between wines and various citrus fruits. The right bottom figure explores the compatible food pairings, showing how common food can enhance flavor of specific wine and citrus fruit. Still, they did some small experiment testing the FlavorGraph to predict flavor here on the left side. The next research work dived deeper on the prediction modeling. Published by 2 months ago, Michael Shields and his team focused on the over 200 brands of Belgian beer. They get the spectrum data of the beer and define and a set of flavor description, and then find and train a bunch of people to test and describe the flavor for their coffee, their beer samples. And then also they get data of customer rating by crawling online beer forum. Their results shows some flavor prediction, and on top of that, they find some beer flavor enhancement ways. In their data modeling, they integrate the chemical analysis data, customer review, and the beer tasting data, and then they split this data into 2 data sets for training and later testing the model. So 10 machine learning models are trained with the training data set to build a linkage between chemicals and flavor. And they find that the gradient boost model wins, giving the highest R-square value on the testing data set. Additionally, they use the sharply addictive explanation to find the key flavor influence by calculating the impact of each flavor on the data, and then using game theory. So in the results, they found that the ethyl acetate was identified as the key influencer on the beer prediction. So we can see that the big progress of beer for the flavor prediction by the power of machine learning and data science. But to progress further, we may need a systematic way to describe flavor for all kinds of food. Another difficulty is some flavor come from interaction of different molecules. So looking ahead, there is a large potential of enhancing food healthiness by food flavor prediction.